Good morning. Am I audible?
Yes, sir.
Okay, good. Let us wait for a couple of minutes. Good morning again. Let us get started. Let others join slowly. So I'll share the presentation. Is the presentation visible?
Yes, sir.
Okay. Okay. So as I said, I would just like to ask if there is any question that you have. Yesterday there was a question on TDD. So I have included it in the presentation now. So I'll talk a little bit about TDD since someone mentioned. Is there any other question that you would have on the SDLC models? We have talked about different SDLC stages, and we have taken a look at evolving ways of how these stages are performed by an organization with minimal or relatively more extensive involvement of the customers through either the simple waterfall model or somewhat refined iterative incremental model or verification validation based V model or prototyping spiral. And we started talking about the agile model, which we will talk about a lot more today again. Is there any question, friends?
Sir, are the models that have been discussed mainly meant for like backend applications like servers or other things like because GUIs and all, at least in my experience, are very hard to test. So like how are they tested?
Oh no, that is it is not. These are all generic models, so they are not meant for either backend server applications or specifically for front end. They are all mixed. Testing a GUI really is a challenge, but primarily there are two approaches. I should not say two approaches, two stages in which you do. Certainly, a part of GUI testing has to be manual, because you are really looking at a user interaction. So you test it manually. So what becomes difficult is not testing the GUI, but automating the tests of GUI. Like you saw unit tests or application test in terms of the booking application we are trying to do in the assignment 3. It is automatable. So which means that if I subsequently make a change in the application, then I can simply run those tests again to see that, well, nothing has failed. I mean, the change is consistent with the way it was working, and maybe some more tests will pass. So automation is a big part of testing. And when we talk about testing, we'll talk a little bit more about that. Now, what you are meaning is, but certainly even in this kind of testing, the first round of testing has to be manual. For example, you are producing the golden data for a unit test. You have added two fractions, and you say, okay, this should be the result. The fact that this should be the result, which is called the golden output, is derived from a manual computation or from using some other software and so on, right? So once that has been done, then rest of it can be automated. So that is the big advantage of non-GUI tests. Now, what you're meaning in GUI test is, since it is a human interaction, then you will have to really, every time you make a change, would you have to do all the GUI tests again manually? Because that would slow down the process, that will make the cost very high. The answer to that is no. There are several tools to automate GUI test. So what it does, I mean, I'll try to talk about them a little bit in more detail when we talk about testing, but just the principle is, see, finally to the computer system, if the GUI is being tested to the computer system, it is irrelevant whether a human being is sitting in front of the computer or not, right? Even though it is a GUI. To the computer, it is the input through the mouse, through the keyboard, or through your touch screen and so on. It is the input that is what the computer takes as the input, like any other text input as well. So what you do in automating GUI test is you have event recording software. Like there's a tool called WinRunner. What it does is you play the WinRunner and run your GUI application within that, and then you do a series of manual testing. As you are doing those manual tests, like you are pressing a button, or you are choosing from a drop down menu, or you are writing something in the edit box, or you are choosing a radio, or you are choosing a checkbox and so on, everything gets recorded in the software, in the WinRunner tool, in terms of a test file. And then you save that, and subsequently you can just run that test file, which is a sequence of events that the human being did, which actually replaces the human. And every time in future you run that, you'll be able to actually simulate that as if a human being is testing. So that is how you automate. So there are several such record and replay. This is called record, replay, retest paradigm through which GUIs can be tested. Right. So does that answer your question?
Yes, sir.
Okay. So I'll try to, during testing, I'll try to get some demo of these kind of tools and show you. But you are very right that manual testing of GUIs are a problem. But these processes that we are saying are irrespective of what is your input-output assumptions. For example, if you are talking about a backend software per se, then your input output streams may be text, there may be packets coming in the network socket, there may be database interactions that are happening through certain protocol of database connect and so on. Similarly, GUI is just like another stream, right? So the processes apply, the models apply uniformly for all kinds of software. Any other question? No, let's then start up. I'll just take a very quick look at test-driven development. So test-driven development, as this diagram, schematic diagram shows, is kind of a different approach from the old school approach. In I mean, whatever we have done so far, we have discussed, or traditionally we'll know, is you design for a software, you code, and then you test your code. And depending on the testing, you might go back and change the design and recode and keep on doing that. That's kind of loop. In the test-driven development, which is mentioned here as a new school approach, is you design for a test, and then you code for that test, and then you go back and change the design. So that is this order gets different. So what does that mean? Is test-driven development is not primarily about testing or development. It's not about coding. Test-driven development is about design. You do the design based on the tests. So in TDD, test means unit test. They don't mean all other kinds of directed, integrated, those kind of tests. So traditionally, in what we say is pouting or plain old unit testing, is you write the code and then you do the test. So following TDD, we write the tests before writing the code. You first write the test and then write the code, not the traditional way. Because if you, there are certain disadvantage of writing the tests after the code, because then test does not give you direct feedback to design and programming. It is just giving you feedback on the code. And often what happens is if you write the test after your design, you are or after your coding, then you tend to test the happy path. I mean, during exception handling, we were talking about happy path and exceptional path, because you are then biased with the code and you are testing what you have coded, not testing what you should have designed. Right. So that's the paradigm change that TDD talks about. So TDD basically has a core cycle, which is in the community is referred to as TDD mantra. It says red, green, refactor. What it means is you write a test first, a little test, not a big one, unit test, and a small unit test. Write a little test that does not work. Maybe it will, the code will not even compile for that test. Right. Okay. Then you bring it to green by writing enough code so that the tests pass. You don't unnecessarily write a lot, but you write enough code so as to make the test pass. And you don't spend a lot of time in terms of doing sophisticated design and all that. It's more like a quick and dirty coding. So that's what he was saying, committing whatever seems necessary in the process. But the target is to pass that code. Once you get to the green that your test is passing, then you come back and refactor. Refactor is changing a code from one form to the other so that the functionality does not change, but the code becomes better in terms of design, better in compliant to your coding standards and all of that. So you refactor, eliminate duplications and wrong things in the code and so on, and continue to remain in green. So your code now is after refactor has succeeded, your code passes the test as well as it has been refactored into a better form of the code. And then you go back and write more tests to meet the specification. You keep on going in this cycle. So this is the basic principle of TDD. So this is what is called the best practice. Make it green and then make it clean. Making it green is making the test pass somehow, and making it clean is refactoring to make it right. So the three basic laws or principles that you may not write production code unless you have first written a failing unit test. That you do not start with the coding. You first write a test that fails. Then you may not write more of a unit test than it is sufficient to fail. You do not write a lot of test, but you write only enough test so that your current code fails. And then you try to take it to green by writing production code so that this test can pass. And then again, you do not write a lot of additional production code. You just write enough code, sufficient code, so that this failing test will now pass. Right? and then you refactor again. So based on these three laws, the TDD goes on. This is the overall life cycle. It looks very different from what we have seen so far. So if you look at the left, and its red bubble on the left, check whether the test fails. If the test succeeds, then you rewrite the test, because you have to write a test which fails. So you rewrite the test and make it fail. If the test fails, then you write only enough code to make it pass. If it does not pass, you come back and keep on writing the code for the test to pass. Once it passes, then you go on to refactoring. So you are coming to the right side in the green bubble. You see whether all tests have succeeded. If all tests have succeeded, then you refactor some code. You keep on doing that. That is, you are improving, you are trying to improve the code. Improve but making sure that the tests still pass. Now, if some test fail, then you correct the regression. That is whatever the past results and all that, update the failing tests, and then you come back and check again whether all tests have succeeded. So you keep on being in this refactoring loop to improve your code till you come to a point where you have all tests passing and you have nothing more to do. So you go back from right to left again in the iterate and check whether you can write a test which fails. You keep on doing that. So the completion here is defined by test. So the contract, the commitment that you have made to the customer is being viewed as a set of tests which has to pass. And the focus in refactoring is to align the design with the known requirements, right? So this is the basic idea of the test driven development. As you can see, that it is not talking about the overall process. That's the reason I initially did not include it as a part of the model. And TDD can be used in some of these models, naturally in waterfall or in iterative incremental. You cannot use a TDD. TDD needs a more agile kind of method. So, but we will see at least one example of where TDD is used. So this is a style that was introduced a couple of decades back and is used to a certain extent in terms of the agile methods. So there are certain positive benefits in terms of having a better design. You get a cleaner code because you are regularly refactoring. It has a safer refactoring, which increases the quality naturally. You have better code coverage. That is, you have not written a lot of code. You have written codes that pass the tests. You have just written, that was the law, right? So the code that you have written, it's most likely that you have at least one test which goes through a particular line of the code. You cannot have, it is unlikely to have code which is not covered by any test. I mean, the code which no test is testing actually. So the test actually here serve as your documentation. So it gets faster to debug, uh, because most often the failing code, you have seen the global life cycle. So most often the failing code or the test is the most recent changed code, because earlier everything was passing, right? So it is called a self-documenting test. The tests show and indicate how to use the code. So test takes the central, part of the central role in this development. That's why it is called test-driven development or test-driven design. Of course, you need, tool support, language support in terms of that. So there is a generic framework called XUnit, which I have given here. This greens mean these are all links. So you can go to that link and study more about them. So there is a generic unit testing framework which talks about, irrespective of the language, what kind of unit test requirements you have, what kind of unit test features you should be having, and so on. And then whatever you see on top are different kind of language specific or platform specific instances of that. So if you are using Java, then XUnit has a version called JUnit, Java unit, where Java is extended with XUnit components which help this unit test process. C++ has a corresponding CPP unit. JUnit is actually a lot more popular than CPP unit because C++ often is more in terms of the system's uh, coding, at least at the time when TDD evolved. I mean, C++ has migrated to multi-paradigm aspects a lot more in the later 2 decades. In Python, you have a PyTest component, unit test component, which help you do TDD. In .NET framework of Microsoft, you have a version of XUnit called xunit.net and so on. Now, interestingly, there's a language I was talking of called D language or DLang, which builds in unit test as a part of the language feature. So it is kind of derived from C++, but it is not like the C++ pair, where C++ is backward compatible to C. DLang is not. DLang borrows again from multiple languages, more heavily from C++, but it borrows from other languages as well. And it's a new language people are trying. And one of the features, D language has several interesting features. You can go to this website, DLang website, and learn more about this language. You can download a working compiler and so on. It's a good fun stuff you can do. In terms of unit test, this is an example. So this is a class which is pretty much like a C++ class. But what is interesting, you can write a unit test. Unit test is kind of a function. It's a kind of a member function, but it's a keyword unit test where you have written a test. So you say that I have a sum, which is a sum object created new, and I have an assert which says that sum dot add. So sum is an object of this class. So sum dot add 3 4 if I take equal to 7. So this is humanly put, right? But once you have put this becomes an automated test. So you're saying that if I on this new object, if I add 3 with 4, I must get 7. Otherwise, I raise an exception. Similarly, add sum dot add -2 0 has to equal -2. You can add more of these asserts to check different conditions. So the way it works is when you instantiate the first object for the sum class in your code, this unit test will run. Subsequently, you know that it is okay. So if you have made any changes to the sum class, then it has to ensure that this unit test is actually passing. So the first instantiation will always run the unit test, right? So this gets built into the language. You will not have to run a separate test. This is another form where you have when you have a parameterized one. So you're saying that my func is a template here is in a different kind of notation, but this is this is actually what we learned as template in C++. Func t, that is the type variable here, and then you are using this t. So you have an array whose element type is t. So if data dot length is greater than 2, there's more than 2 elements, then you assign data 1 to data 0. That's a kind of a meaningless stuff. Don't worry about that. So the unit test here is you do auto ARR. Auto is in a similar sense that we have learned auto. So you are explicitly instantiating an array. So you know that it will have 3 elements and so on. Then you call myfunc from the unit test. So it checks this, and you assert that on 1, 2, 3, the length will be 3 greater than 2. So you assign data 1, which is 2, to data 0. So after myfunc, ARR should become 2 to 3. So you're asserting that this should be equal. So this unit test will get invoked automatically when myfunc is invoked for the first time. Myfunc is called from the code for the first time. So it checks that the function. So this is kind of an example of a unit testing in a class. This is an example of a unit testing of a function. And then it has some more attributes. It has a no-throw attribute, which says that whatever you are unit testing, that unit test actually will not throw anything, except for this when you have assert. And it is these are more DLang concepts. But this is how kind of a TDD infrastructure works. So this is just to give you an idea of how a little kind of a different paradigm can work in terms of software development. Let's move on. Let's get back to agile. We want to talk a lot more about that. So agile, I mean, I'm just trying to compare the philosophy, because in agile you'll slowly see that we are moving into something of a very different style of developing code. So in waterfall, if we look into the, this triangle of the basic parameters, that obviously one parameter is the time to deliver the features. One parameter is the cost, and one parameter is the scope. Scope means the functionality that you have covered. And certainly the most important parameter is the quality. Now, in waterfall, what you basically try to achieve is you achieve the 100% of the scope, all functionalities, everything covered. And to fit in the cost and time that are given, you will compromise on the quality. So the quality keeps on varying. Right? So that's the reason projects fail. Whereas in agile, you make the triangle different. The three vertices of the triangle, cost and time, remain same, but the third becomes the quality. You ensure that the quality is correct, and the varying parameter becomes scope, that you may not actually complete all the requirements. It depends on how much is doable in this cost and time. And since you want to vary the scope, in agile, necessarily customer has to be in the loop, because customer has to understand and agree that this change in scope is acceptable to the customer, right? So this is the basic idea. The same thing written in a different form. So here, the estimates are on cost and schedule time. It's driven by the plan to meet the requirements. Whereas in Agile, the estimates are based on features, and it's driven by the cost and schedule on the other side. So it's just, so this is kind of the uh, Agile approach, which is quite somewhat different, and there are different Agile methodologies that exist. So we'll take a very quick look at extreme programming first, which is been pushed in the early evolution of the agile methods. It is not, I would not say that this is very, very popular, but it brought in first, the concept of agility very strongly, and then about Scrum, which is a currently de facto standard of development in several companies. So in extreme programming, the idea is it is an agile method which was created by Kent Beck, who was also the proponent of the strong proponent of TDD, right? And he has an excellent book. You can try to get this book and read it. It's a gem of a book which talks about the core issue of software development, that it can continuously change. So it is subtitled as Embrace Change. Make your processes such that you are agile to accept change at any point of time. So this is kind of the agile loop. It looks very different from any of the process loops we have seen. At the bottom of it, you have to see that this is cyclically going getting bigger. And if you look at this right hand side, you'll see that the time granularity is changing, second to minute to hour to day to days to weeks to month, right? And you keep on iteratively growing your activities till you get to a one kind of a 1 month 2 month resolution where you do releases. So at the core of it is the development, which is called pair programming. That's again a very typical concept of extreme programming, XP, where every development is not done by a single individual, but by a pair of individuals. So they are coding every second. They are doing, uh, you know, every second they are doing coding together. Then you have, every couple of minutes or 15 minutes, half an hour, you do unit test. So this is the TDD that gets built in, and you again continue doing the coding. Now, maybe after an hour or 2 hours of development, the pair the two people who are developing, the driver and the observer, they get into a negotiation. They discuss, are you doing things right? Is overall going okay, and so on. So it happens couple of days in a day, and then every day you do a stand-up meeting. A stand-up meeting is you do once every day. It's a stand-up meeting so that you are not supposed to sit on your chair. You're supposed to stand by the side of the cubicle and do the meeting. This is to ensure that the meeting remains short. So it's typically a 10 to 15-minute meeting where the pair and multiple pairs discuss between themselves about the development, about the progress, about the difficulties, about the roadblocks, and so on. And then after a couple of days, maybe 7 days or 10 days and so on, you run the acceptance tests. These are beyond the TDD unit tests. These are bigger tests where the module is getting tested. And then after a couple of weeks, maybe 2 weeks, 3 weeks, you check whatever you had to do in this iteration. You can see that this smells like iterative incremental, smells like spiral, but it actually internally doing things very differently. Then you check on the iteration plan and define new targets for your next iteration and so on, so that after 1 month or 2 months or 3 months, you can meet your release plan. And then you keep on, going from release to release. So that's kind of the basic approach that XP takes. And you can see that this is pretty agile because you are you are putting checks and balances at multiple granularity of the time. You're making checks even at seconds and minutes to make sure that at every point, and the pair, the person who is the observer is your check, is your safety net. And you keep on then increase the granularity of time so that you can keep things naturally manageable in time and cost. If you naturally keep on only just doing checks, then you may achieve a better quality, but certainly will lose out on the cost, right? So this is the overall philosophy. The core concept in this is it starts with what is called a planning a game. So a game is nothing but a meeting. So it occurs once per iteration. So typically once a week on the iteration it will happen. And it does two kind of planning process. One is the release planning. I'll go back to slide 45, the release plan on the top. So this is something what will get released. This is what the customer will get. So you do the release planning. So in the release planning, customer and developer both are involved. Whereas another planning game is about iteration planning, which plans the activities, tasks of the developers, the pairs within one iteration. So customer is not involved in that. So this planning game is the driver of this extreme programming process. And it goes by 12 practices in 3 categories. There are 3 management practices, which is on-site customer. This needs that one customer contact who is knowledgeable, who is competent, has to be accessible always in order to clarify requirements, answer questions directly. Planning game, as we saw, planning for release as well as for iteration, and manage the short releases. Every time, during every short interval, there has to be a release. The customer has to get the release, give its feedback, and that has to come back to the team. So this is what the management team, the project manager and so on, have to do. The next are team practices. That is, what should a team do? It should use very few metaphors, very clear metaphors to describe the system. There has to be a collective ownership. The whole team is responsible for the system, just not the project lead, not any individual. So every developer has access to all lines of code. So if a developer is indisposed, another developer can pick up her task immediately. There has to be continuous integration, which is, of course, the part of TDD. It must follow a coding standard, and it has to go at a sustainable pace, because as you can see that this is not going through a very formal requirement analysis, design, these kind of processes. This is innovating as you go. This is being creative at every stage, with every individual project member building up. So if you are overworked, you will not be able to deliver well. So overtime is not what is advised in extreme programming. So these are the 5 team practices. And then you finally have programming practices, where you have testing at the top of it. All development must be testing, and TDD is the preferred paradigm for that. Designs should be kept at the as simple as possible. Refactoring, of course, you need to refactor to improve quality, and this is what TDD needs. And the core of it, which distinguishes extreme programming from any other practice, agile or non-agile, is pair programming. Two programmers work together at one workstation. One is the driver who is writing the code, while the other is an observer or navigator who reviews each line of code as it typed in. So since two people are doing it, it is very likely that most errors will get caught while they are being written. And the two programmers will keep on switching the roles frequently, so that observer might get bored otherwise, and even the skill wise both need to have the same skills. So two programmers will keep on changing the role, and observer has besides checking every line of code, the observer also looks at the strategic direction. What are the possible ideas of improvement? What are the future problems to address? Whereas the driver focuses on the tactical aspects, completing the current task, using the observer as a safety net, because driver knows that while she is working, if there is some mistake made, then it is very likely that the observer will catch it. So she does not have to spend a whole lot of time to ensure that everything is every tactic taken is absolutely correct. She will innovate and keep on taking approaches so that the current task can be completed, and the observer will make sure that the quality is not getting compromised, or errors are not getting committed. So it's a very different kind of thought style of doing things. 4 programming practices total of these 12 practices define extreme programming. Naturally, it has a lot of strengths. It can reduce cost and time required for project realization. You are using very limited documentation. You are using test set documentation, so you save a lot of money. Simplicity is a main key factor. Simplicity leads to faster completion, less defects, and so on. And it overall it reduces the risk to programming. Using modular structure, pair programming spreads the risks because it's between two people and so on, TDD and so on. But it has a lot of weaknesses, because extreme programming is always focused on the code rather than the design. So if you have a more complex system, this might lead to a lot of difficulties, because you do not have a robust design to actually fall back on. It requires detailed planning from the start due to change of cost and scope at every stage. So the iteration planning has to be very, very solid. It does not measure the quality, and so on. And the most critical weakness for which extreme programming often has not been that successful is the fact that there are often interpersonal issues that happen between the pair. you know Someone is more competent than the other, someone is more dominating than the other, and so on. So human management becomes a project management challenge often in terms of implementing this pair programming concept. But this is another approach which is, as you can see, is more radical. So having said that, let us come to the core of it. I mean, what we are seeing slowly, I mean, you have seen the SDLC models, waterfall to all these, which has a well-defined stages, customer engagement at minimal to relatively more. So you have a very structured process. And Agile is breaking all those rules. So I just bring to you certain examples from cricket, because I'm somewhat of a cricket fan. So on left, you can see a known batsman from India. I'm sure all of you will recognize him, doing a sweep shot, which is called a copybook shot. That is known for centuries, so to say, W.G. Grace and even earlier. But at a certain point of time, there was a disruptive development that started happening in cricket. You started doing a reverse sweep, sweeping in on the other side. So you do a sweep on your leg side. The reverse sweep happens on your right side, right? So this disruptive thought process of looking at things differently brought a lot of success to a lot of batsmen. Right here, I do not know whether can anyone recognize this person below, this batsman below? Is there any cricket buff here? Non-software engineering question, but can anyone recognize him? He's from Pakistan. Yes? Any attempt? No? Okay. He is Mustaq Muhammad, younger brother of Hanif Muhammad of Pakistan. Mustaq Muhammad is attributed to have first innovated this reverse sweep, right, which changed the face of batting. If you look at the bowling side, you also had disruptive developments. I mean, swing bowling, in swing and in swinger, which swings into the batsman, and outswinger, which swings away from the batsman, has been well known for centuries. Again, conventional swing, which happens when the ball is new, and one side is getting rough, and other side is smooth, but it typically happens on the new ball, and fast bowlers are known to do swing bowling. Till it was innovated that you can do a swing also with a old ball, which has a very rough side, because beyond a certain speed, about 70 kilometers per hour or so, when you cross that speed, then there's a kind of different kind of turbulence that happens. There was a lot of physics which has been done on this, which allows the old ball also to swing in the other direction than what is expected. So that is why it's called the reverse swing. And again, I'm not sure whether any of you can recognize this person. Can you? This
Sir
bowler?
Hadley.
No, it's not Hadley. He's again from Pakistan.
Okay.
He's Sarfraz Nawaz. Sarfraz Nawaz was kind of the person who first successfully started doing reverse swing in Test cricket. And for that, he had been suspended substantially. He was penalized substantially because it was thought that he was doing ball tampering. Till a lot of physics experiments, finally your wind tunnel experiment showed that it is actually possible to swing an old ball if you cross a certain speed limit. So Sarfraz Nawaz was a pioneer in that. So I mean, these examples are from life, from a different domain. My whole idea is to say that we don't have to always think traditional. We can think differently, and that's what a whole lot of people started to think, and that gave rise to Scrum. The word Scrum, if you are not aware, I mean, unless in India rugby football is not that popular, Scrum is a terminology taken from the rugby football. So rugby, as if you have at least seen on the TV, you'll see that it starts from this formation. Both teams huddle together, and that's called a scrummage or scrum for short. And then they get out, burst out, and play the game, and again come back into the scrum. So that concept is what you are bringing into the SDLC. And the remaining part of the slides are directly from this course from Washington University. So which I did not prepare the slides separately, so you'll see that directly here. So Scrum is not about this process. This is waterfall. It is an agile, lightweight process. It can manage and control software and product development. I mean, at the core of it, it uses iterative and incremental processes, a simple implementation, reduce time, and so on. Let's see what it means. So these are the Scrum proponents, and it has been around for more than, I mean, strongly around for more than about 20 years now. So the Scrum manifesto, the Agile manifesto, which is the core of Scrum, says this is what we have been doing. This is on the right is what we have been doing. We have been focusing on processes and tools. I said process is the key to have quality, cost control, and so on. We emphasized a lot on comprehensive documentation. We talked about contract negotiations, following a plan, and so on. Vis-a-vis here, you replace, I mean, in place of process and tool, you focus on individuals and interactions because they are your real tools. They are the humans. Instead of what comprehensive documentation, you focus on the working software. Contract negotiations are primarily mostly done away with by customer collaboration. Customer becomes a part of your development team. And instead of following a plan, you start responding to change. You have a very short plan, you have short targets, and you respond to change in those targets on a regular basis. So these are the preferences in terms of the Agile manifesto. Let's skip this noise level. So this is the core of the Scrum. Scrum has a typically a 30-day cycle, and it starts with a product backlog. Product backlog is the idea that what needs to be done for the product, what is remaining to be done is called the backlog. So this, you can kind of take it equivalent to tasks, right? But in Scrum terminology, that's called a product backlog. So this is the product owner from the product backlog will prioritize as to what are the set of backlogs which is a priority now. The higher priority stuff will always get done first, and prepares a sprint backlog. Sprint is going round this once. So as you do the sprint backlog, so this is kind of the task set, and that's expanded into backlog tasks by the team to create what is called a burn down chart. We'll come to that. So you try to clear this backlog to create a potentially shippable product increment. Now you do not have these kind of backlogs, the in blue below, have not been addressed yet. So the total product is not ready. But the prioritized part of the product in the sprint backlog has been met by the team by creating their own backlog and clearing that through this sprint of 30 days. And so you have a shippable product, which is an incremental over what you shipped last time. Now, within this 30 days, every day you do a daily Scrum meeting every 24 hours and make sure that things are on track. So what you are doing in comparison to the most of the other processes models that we have seen, that you have to do a requirement, you do a design, do a code, do a test, often in different time scales, often by different individuals. Here in Scrum, you do all of that thing together, but in small parts. The Scrum teams do a little of everything all the time. So you you are doing the requirements, you are doing the design, you are doing the code, you are doing the test. You can see a micro order in terms of this. And obviously the reverse order, it's the same order in which they complete, but it is being done by every individual involved in the Scrum team. Okay? So this is a Scrum framework which says there are three roles. There's a product owner who owns everything. There's a Scrum master who drives the Scrum process, and then there are team members. And there are different ceremonies. One is called a sprint planning, where you decide what you will do in the sprint of 1 month. There's a sprint review to see how far you have done. There's a sprint retrospective. That is, at times you not only review what you have done, but you just look back as to what went well, what did not go well. And then you have daily Scrum meeting. And you use very simple 3 artifacts. Product backlog, what is remaining in the product, which the product owner will prioritize for you in terms of a sprint backlog. And you have a burn down chart. This is a chart of tasks by the individuals and how far they are getting done on a daily basis. Right. So let's just take quick. So this is product owner, which is a product manager, scrum master, who is a product manager or team leader, who is enacting the scrum practices, you know, remove impediments, I mean, inter-team politics and so on, keeps everyone productive and so on. And then you have a project team. It's the ideal, Scrum recommendation is to have a team of 7 members, not exceeding 7 members. It varies from 5 to 10 members, and the teams are self-organizing, which means that you know in a traditional, more traditional model of development, there is some designer, some developer, some architect, some tester, and so on, some integrator, and so on. Here, it is cross-functional, so the team members keep on switching their role between being a QA, being a programmer, being a UI designer, and so on. And a membership does not change within a sprint. Within a sprint, the membership is fixed. If you have to change a team member, it happens only from when you go from one sprint to the other. Let's skip this fun story. You can read it later on. So in terms of the ceremonies, the main thing is the sprint planning meeting, which takes in these two inputs: team capacity and the product backlog. Based on that, the sprint prioritization is done, analyzing and evaluating the product backlog and selecting the sprint goals. That is, in next 1 month, what we'll do. That gives you the sprint goal. And then you have others also considered for the sprint planning. Decide how to achieve this sprint goal. What is the design? Create sprint backlog, the set of tasks that need to be done within this time from the product backlog items, and estimate the sprint backlog in terms of hours. You do a daily scrum meeting. Again, it is about 15 minutes, typically stand-up meeting. Anyone who comes late pays $1 fee. Okay, that's to keep things on time. This is not for problem solving. You don't do brainstorming here. Everybody is invited, but only team members, scrum master, and product owner can talk. Others can be just listen to it. But you don't solve technical problems. You don't do brainstorm here. It just tries to answer these 3 questions. What did we do yesterday? What will you do today? And what are the roadblocks? What are the obstacles in our way? So you can see that Scrum is a more like a philosophy. It's not only applicable to software engineering. You could apply to Scrum processes to our any other daily or periodic tasks as well. And this helps to avoid lengthy, time-taking, unnecessary meetings. So I talked about this artifacts. Let me show you, and most of these can be managed using simple tools like Excel and so on. So these are product backlog. So what you build are user stories. Of course, instead of use cases, it is saying, so you still do not know what use cases are. That's a part of the UML model that we are going to discuss next. But in Scrum, most often you do a user story where you answer these 3 questions. For any feature, you answer these 3 questions. Who is the user? Who is the role? A customer, employee, admin, etc. What is the goal? What is the functionality that has to be achieved? And why it is important for the user to achieve this goal. So typically, this is a story. As a user role, I want this so that I can, like, as a user, I want to log in. That is the user role. I want to so that I can access the subscriber content. Hey, so every story is given certain points. These are kind of kind of heuristic. You give a point in a scale of 1 to 10, or by shirt sizes, extra small, small, medium, and so on. And so this is kind of story points you give. So this is kind of estimates for how much it will take to do that part of the story. There are detailed product backlog samples I have given, sprint backlog samples. So let's say this is what a sample sprint backlog is. For this particular week, this task has these story points. So these are kind of hours, man hours that will be needed for achieving these stories. And so again, detailed samples. And based on that, you compute the burn down. The burn down is how much of it has been done. So this is, you would want things to go straight down, but it goes like a cranky way, say. So this is a typical burn down chart from day to day. So let's say a more detailed example. So this is what has been done on Monday. This task, so much has been done, 8 hours, 16, 8, 12. So if you add up, it is about how much? 20, 44. So you have 44. Here you have 20, 32. So this is the way it is getting burned down. It is getting done. So burn down chart tells you about the progress. So if you have a flat chart, no work is being performed. If you have this kind of a step chart, then it is being performed, but not fast enough. If you have this kind of, then you are probably going too fast, you know. So these are different kind of analysis that you can do. You can do a sprint, then you periodically do a sprint review, which is informal. It is a 2 hour preparation time. It's announced 2 hours before the meeting. So it's not that you're spending weeks preparing for your review meeting, and you are not allowed to use slides. You have to just talk about it, right? Show the software. So this Scrum makes it, very scalable process. It has been used for multiple 500 plus person projects, and you have, since you have teams of 5 to 10, what you do to scale is you do Scrum of Scrums. You know, you do meta teams of that. So we'll not get into those details, but it's finally just the comparison of waterfall, spiral, iterative, and that's what we are interested in. You can see in waterfall everything is planned and predefined. As you go spiral, it gets less. Iterative, it gets less. A lot of things are getting said during the project, like even the final project, the final cost, the completion date, because the customer is in the loop. And then these are the responsiveness is always there. Here it was only on the planning side. Team flexibility is unlimited. You do a knowledge transfer, you do not have a separate knowledge transfer, you do it during the project. And that all leads to a high probability of success. And that is the reason most of the companies today, to a big extent, are following the Scrum methodologies. And as you join the job after your graduation, I'm sure you will be using Scrum pretty extensively. Somehow, we were pretty somewhat late, so we lost all the, consumed all that time. If there are quick questions, one or two I can take. Otherwise, we will continue after the break. Any questions for now? I think you are getting late for your next class. Okay, let me stop here. On that was an overview of the software development life cycle, and we will move on to the next topic after your spring break. I'm sure your spring break starts tomorrow and ends on your third. So we'll meet after that. Have a nice break. Enjoy yourself. Recharge yourself, and see you on fourth.